And it needs explanation. I'm not saying he's correct, but I'm going to listen and let's ask him questions.
Right, good morning everyone. Are you all sitting comfortably? Just to start off with one or two announcements, excuse me. Because we have various different travel arrangements for people. So I have left out a list in the dining room kitchen, so that you can actually hook up with others who are going in the same direction. I've already misunderstood some of the directions anyway, it was only guesswork. And there's some websites on there, and you're welcome to use my landline if you want to book taxis so that you can taxi share, because I know some of you are leaving this afternoon, but I think most of you are actually leaving tomorrow morning from, and I need to add you onto the list actually.
Sorry, I mustn't.
Professor Assis also needs a lift tomorrow morning to Taunton Station, so I need to add that to the list. So I'll probably update it at some point. Anyway, it's with great pleasure that I hand over to Philippe, and he's going to talk about, I've already forgotten.
Basic physics, okay. Wait.
He's from the LENR projects.
Yeah.
He's London and North Eastern Railway.
Good morning, everybody. I will speak not about binding energy as it is written on the document, actually, but more about basic physics. Let's say mass, electromagnetism, and also the two nuclear forces interactions. So we know that matter is the basis for physics, of course, but we don't know what is matter. This is a problem. So matter is characterized by mass, electromagnetism, etc., etc. Matter is also featured by the fact that it is made of basically neutron and proton only. Of course, it's a bit more complicated, but basically these two nucleons, and it's in fact one nucleon, is the basis for matter. So I decided to study this neutron, and also to look for first mass of that neutron, and then to see if it is possible that there is a relation between that mass and electromagnetism, weak nuclear forces, and strong forces binding energy. This is the way of thinking. So I will not use a lot of math today. It's not necessary because I work with matrix. I work with matrix because the following: we have to work with space and time. If you put that in an equation, it's lost. You will see immediately. I will explain you why I have put lines and why I have put columns, etc. Because it's for space and time, actually. So the reason why I work with that, do not be afraid by that. It's relatively easy, and more easy than to work with equation. Of course, I have equations, but if I use this equation, it is stretched together, all that. And so you could not see the instant 1, 2, 3, 4, 5, etc., or the number of columns, which is important also, as you will see. So I studied first mass, because I had to begin with something, and mass seemed to me the most important, because it is the most component of matter. At that time, when I began my work, I didn't know anything about the Higgs boson, because the Higgs boson was discovered 2012, and these works are anterior. So I had only the particle Z0 at my disposal as a particle which is beyond the neutron and the proton. So I discovered that this particle Z0 is actually equivalent, more or less, to 1,800 multiplied by 100 electromasses. I have forgotten to tell you that I work with electromasses because of the charges also. If you work with electromasses, you have the mass of the electron and the charge of the electron at the same time. So it's easier. This is the basis of work instead of math. Of course, we convert it in math later. So I saw that this particle Z0 was in relationship with the mass of the neutron. The mass of the neutron I divided for that reasons in 18 multiplied by 100 electron masses, as you see here. I will just show you with the pointer, 100. This is one of that mass. There are 18 other masses, or 17 other masses, to have 18 at the end. So I looked how I could derive this 100 from the particle Z0 and from the neutron in order to come to the given mass of the neutron, which is acceptable with the literature. You will see that I have to use mass and antimass according to the equation of relativity as well as the equation for quantum mechanics. Actually, you can use both. So the mass of Z0 is much bigger than the mass we know. So for me, it was an evidence that I had to use antimass, that I had to take positive mass and also negative mass in order to come to the figures of masses we know, actually. So this is what I did. I divided, as I told you, this by 18, each 100 multiplied by 18. And so I gave to each instant, because now we have to speak a bit about time, a decay of 1%. Could have been different. I have tried different ones with the computer, but it's that one which worked. And of course, I use also the antimass. Look here. You have first a decay of instant number 1, a mass of +1. Second, at the second instant, there is a negative mass and a positive, which is more important. Each time 1% more. Resulting mass is Z1. Plus, plus. But there are different columns. I will explain the columns in the next schema. Third instant, minus, antimass, plus mass, which is always a bit more important because it has primacy over antimass. They are equivalent, but in fact, but not in time. This is the point. It's the reason why I cannot work with equation, but I have to work with this time and columns, etc., in order to demonstrate it. So this is the resulting mass, etc., etc. At the end of the process, instance 18, we have a resulting mass of, which is a bit bigger than only 1 electron mass, which is 17 hundredths of 1 electron mass, etc., etc. And this is the same for all the 18 ones. So I show you now the result on the second, here. Here is only the result, actually, because I cannot put on a matrix too many figures, but you have to imagine that these figures, you see, are in fact mass plus antimass. Here I figured only the mass, the positive mass. If you do like that, if I do like that, you see, I have here what I just shown, 1, 1736, etc., etc. For the others I have the same, but at an instant before, because they do not work at the same instant. They do not work at the same time. Again, they do not work, it's the reason I have the columns, at the same scale, because it's always 100 times less. So I put 10 minus 2, 4, till 10 minus 34. Why 34? Because at the end it's exhausted, and also because gravitation is intervening compared to the forces, the nuclear forces at the level of 10 minus 36, 38. So here we are at present, without gravitation, it will come. It's mass. Actually, it's not gravitation, it's mass. So this is a table showing the result of the mass of the neutron. Actually, there are 4 tables like that. You see here, you figured the second one here. I have not put them on the table, on the bed, because it's impossible to do with no space. If you do that, you find a result of the neutron mass, which is about, I have to read it, I can say it in math, is 939.55, etc. math, which is exactly the mass of the neutron. Okay, it could be a coincidence, of course, because one thing is not a proof, but I have other coincidences. So it gives a certain weight, if I may say so, to what I'm saying. That is still an hypothesis, of course, it's my hypothesis. So this is, let's say, the mass of the neutron. So I tried to do, after having found that, to do the same with electromagnetism, of course, because you are interested with electromagnetism more than at mass, but you will see that electromagnetism is much more important than foreseen. I came to the same result, let's say, the magnetic moment in the nuclear magneton of the neutron, which is about minus 1.913. This is the result I found. I find the same things for the proton. So there I have 4 coincidences. I will show you. Yeah. Second point, constitution of electromagnetism. You have here the same than for the mass. This is mass. Electromagnetism, I figured it at the right side, you see? These little signs is minus, plus, is electromagnetism. The rest is still mass plus antimass. It's exactly the same, but it intervenes again a little bit later. And it intervenes a little bit later, again this matrix, this is the reason why you have this matrix. It will be a bit less important in terms of electron elements. This doesn't mean that it's not important. But you see here we have the instant 1, again, electromagnetism is equal to 0, when it is equal to 1 for mass, etc., etc. So the electromagnetism here is less important in terms of electron elements than the mass. See, in this hypothesis, the line 18 we have just seen before should have, because it's still an hypothesis of course, an electromagnetism resulting of this one. So if I do the same operations for all the 18, with all the 4, etc., I find the electromagnetism or the magnetic moment abnormal, which nobody has explained up to now. I explained it. For the neutron. So electromagnetism for me is a condensation, so it's a French word. Maybe there is some problem of translation. You have to know that I'm not typically French. I'm French, politically speaking, but I am of German origin, or better to say, I am from Alsace. And we are Germans, but even if we are politically French. So I speak French better, but I think in German. And then translate it in English. So it's a bit difficult for me sometimes to work with. So condensation is more... oh, sorry. Condensation is a sort of French word which was translated in English, but this is a translation of the German Zusammentreffung. German is much more precise for... I prefer to, not only because I am of German origin, but I prefer to use German for physics, etc., because it's much more precise, I would say. Zusammentreffung, etc. which is not exactly the same as condensation. Yeah, yeah, yeah. We can discuss again, but okay, condensation is a word, a French word, just saying okay, it goes together, and it is annihilated in a certain way. Electromagnetism it's a condensation of mass plus antimass. First of all, because mass is a condensation of mass plus antimass, but again, and then antimass plus mass, resulting in a negative electromagnetism, and after that a positive electromagnetism. Actually, mass plus antimass is working as a result of negative electromagnetism. Antimass plus mass, which came later, has as a result a positive electromagnetism. It's the reason why the electromagnetism of the neutron, let's say the magnetic moment, is negative, that one of the protons is positive. So I will demonstrate it. The whole process presents a slight excess of negative electromagnetism, as you have seen, which is the dipolar magnetic moment of neutron. In reality, and this is important, I don't know if everybody sees it, in reality, there is huge electromagnetism, much more, negative and positive, which is produced, of course, it's produced, but it annihilates. And this we will see, the new physics is able to demonstrate that within the neutron and the proton, there is a lot of electron and positron together. I cannot now explain it. I need a dashboard, etc. I can try. Just a moment, but I need something to write. Etc. You see, electron negative. The negative is first. It is annihilated by the positive, so it's zero. Then comes again a negative. So it is negative, but comes again the positive, etc. So at the end there is always a tail. Exactly. It's a wave. It's a wave. There is always a tail which is negative, and this tail is equivalent to the magnetic moment of the neutron, which is very, very weak or a little one. So it works like that, according to my theory. Again, I'm cautious. Huh? It's my theory. So we can create, or we can let's say demonstrate not only the mass of the neutron, but also its dipolar magnetic moment, which is abnormal, that nobody knows about it. Using exactly the same procedure each time, you see, you have seen, I use the same procedure, the same matrix, etc. I demonstrate it. Of course, I have also on my blog, on my website, a whole demonstration I cannot give you today for obvious reasons. So, we saw that the line 18 decays in the way I just showed. The other lines of the neutron, because there are of course others, at instant 18 should have respective resulting electromagnetism of so and so much. Because they are not acting at the same time. So when the line 18, the first line, has fulfilled all the boxes, I would say, the others have not finished. This is the reason why the neutron decays. I will demonstrate it on my blog today. So this is the way it is shown. I give you. Sorry, I forget. So you see, a lot is then a lot of electromagnetism, as we have seen, is forgotten. For instance, a line +2 +1, no, a line 1 2 1 is the condensation of +2 +1 -3 -2, etc. Actually, there is an energy released, also quantified. All of that is quantified, of course. An energy quantified of that one. You see? Conjunction, again, these are French words. I do not like them, but I use them. This conjunction is creates energy, electromagnetic energy, which will serve to release the electron of the proton later. So see, I explained this, that energy accumulates in the neutron according to the mass appropriation. This is the term I have used to create that mass, and will be released in the frame of the reverse operation when the neutron will transform itself into proton. It will serve to eject the electron created. You will see that the electron is created according to different various energies. Nobody explained that. I explained it. Because it is due to the lines. The electromagnetism we have seen, just a little thing, I call direct electromagnetism, because later on the direct electromagnetism is moving in indirect one. It's a bit complicated, I'll leave it out, but if those interested can look on my website. So I have made a schema dedicated to the indirect electromagnetism. I do not explain now, but you see that the schema is exactly the same, of the same kind than the former one. These lines are annihilate each self to give a line A, value that. A is eliminated by lane 3, etc., etc., etc. So we have a total giving the total of the magnetic moment of the neutron. Here you have not the total, you have only the quarter, because there are 4 similar tables. So, to summarize, I put here a schema of neutron, and mass and electromagnetism. In this hypothesis, again, I'm always cautious, can be considered a quadrupolar system. The neutron is a quadrupolar system, schematized as follows. You have a basic mass, which is the mass of 1,800 plus 18 and once 17. Why 17? You see? Because the 18 ones of this 17 come in when the neutron becomes a proton. And it's the reason why there is a system of ejection. Because the neutron has a tendency to recover the position of a neutron, etc., etc. It's the reason why there is always ejections of electrons, and with different energy, because the energy is that one of the different lines. So you have here the figures which are globalized, and you can see that the mass is that one, 1,838, etc. electron masses, or this in MeV, 939,541 MeV, and the dipolar magnetic moment of minus 1.930, etc. So this gives me a second evidence or coincidence for the distribution of mass and electromagnetism within the neutron. I have 2 other coincidences. It's that one of the proton, because it corresponds. From neutron to proton. The demonstration is a bit longer, so I give you just the end figures, but for for those who want. I have here some papers which summarize my theory. I have only 14. I didn't expect so many people, actually. And for those who want, and also you can look the whole on my website. So in the preceding pages, so one observes a possible connection between the values of mass and magnetic moment of neutron and proton, because the electromagnetism is directly deducted from the mass. It is therefore interesting to search for a simple transformation allowing to pass from neutron to proton with respect of these values. So I did a very rough calculation. Exactly, it is just the result. The calculation is a bit more complicated. The result is the following. You take the result for the neutron, you deduct some results from the electromagnetism, and you find figures which are in line with the mass of the proton, 938.25 MeV, and for electromagnetism this is 2.793, etc. Okay, so this is absolutely correlated. So it's of course an hypothesis, but I have 4 coincidences. These are not the only ones, because you know that I spoke about 4 forces, 4 interactions. We have here mass and electromagnetism, of course. Afterwards we have the weak energy, the weak nuclear energy, transforming the neutron into proton. I haven't figured it out, but I have just spoken about it. The loss of mass is in line with that theory. Again, the modification of the magnetic moment. And the magnetic moment is positive because the neutron is losing a little bit mass. Let's say it's going in a sense opposite of the time, for a little bit. I explain why it's only a little bit, because if it's all the time, the result would be 0, of course. So this is what I found for neutron and proton. Also for binding energy now, because it was written that I have to speak about binding energy. You have to take, just a moment. I come. This is the mechanism of acquisition of the neutron mass. If you take some of these lines, you will find the binding energy of deuteron. You just make an average of these lines, and you multiply it by 4. Afterwards, for that one of the neutron of the tritium or triton, you have to multiply again by 4, but it's a bit, you have also to deduct something. So at the end, 4 by 4 is not 16, but 15.25, etc. And for the alpha particle, you have to take the whole of that, plus the whole of that corresponding to the proton is the mass, which is that one which has been lost during the binding energy operation. This is what I wanted to tell you. Now I have new elements, which is, as I told you, the Higgs boson. The Higgs boson is very curiously the mass of the Higgs boson is corresponding to what I am demonstrating, and I didn't know that because these works are anterior to the discovery of the Higgs boson, which was discovered 2012. So these works are. So I can just give you the figures. So if you take this figure multiplied by 100, it's the same as that one of Z0. If you use these ones, 171, you have to know that 171 is 1 plus 2 plus 3, etc. It's a sort of, what was it in English, series. And you find the mass of the Higgs particle, the Higgs boson. So, okay, we can think what we want, but what I would like at that stage to discuss with you, with others, of course, on these results. You see, because it's still an hypothesis, we have to be cautious. Nevertheless, with this system, we can discover a theory of the four interactions. Actually, mass, not gravitation. I come to that. Mass, electromagnetism, weak energy, and strong energy or binding energy are really put in one, and it's only with a system of plus minus, mass plus mass minus, that you can demonstrate or find the same figures than which are in the literature. So it's a result, but it's just a result, of course. But now I am more or less specialized in binding energy. Why? Because there is a lot of literature about, and I can easily find the binding energy of all the elements with a very easy system. Edo can tell it apart. So this is about my system of mass. Now gravitation, because I have forgotten gravitation, but on purpose. Mass is not gravitation, but to have gravitation we need mass. So there is a difference between what we call inertial mass and gravitational mass. Everybody is thinking it's the same. For me it's not the same. For me it's not the same. From a center, say, in the sky, which is everywhere, because there is no time and no space at that moment. A mass is coming in, mass. Okay. This creation of mass creates also a distance between the center, supposed center of the universe, and the mass, the position of the mass, which you can figure out by md. So this has a certain interest. I will just tell you why. The new hypothesis, of course, of the gravitation is based on md hypothesis. So, how to come to Isaac Newton gravitation with that system? Here I just recall this is inertial mass. The mass is put on the sky at a certain distance, exactly like it's said in the Bible actually, but with a system coming from outside the space-time, I do not know, and with intervention of the Higgs boson, which is a particle of God, so we have to ask God what happens, not me. I just look what could be, and I'm doing hypothesis. So we could have a mass of 1 and a d1. If we have a second mass, a gravitation could intervene between the two masses. This is on it. So m2 d2. Now in a system of local universe, which is let's say the Newtonian system, this angle theta is practically equal to 0. In the solar system compared to the whole universe, we can say that the planets and the sun, etc., and all the objects which are in our planetary system are very close. So this means that these two angles are 90-degree angles. Now, if you do M1 D1 on M2 D2, you have M1 M2 on D1 D2. If they're very close, they have the same value, practically the same value. And if you take them in negative, you know that it is equal to the distance squared between the two masses. So we can easily show, this is not a demonstration, but I have no time to do the whole demonstration. You can easily show that the Newtonian gravitation is first not a primary attraction, primary forces. It's not a forces. It's the force of creating the mass, which is the first, and not that one, not the gravitation Newtonian. Then second, there is a Newtonian gravitation between two masses. But of course, if this angle theta becomes bigger, everything is different. Newton is no longer working. So if it comes, you see, very open, what happens? You can see some stars which are going away from us at the light speed. Why? Why is that possible? Because we are also going at the light speed for them. They are, let's say, at another side of the universe. Let's say. And even if they are going on the opposite side, we could not see them. Actually, the consequence is that a big part of the universe we cannot see. Because light speed on one sense plus light speed on the other sense is twice light speed. We cannot see. We can see only on basis of the light speed. So a whole part of the universe is not known by us, according to my theory, of course. So this is what I wanted to tell you. Of course, this opens a lot of things which are of some interest for you. First of all, what is the sky? What are all these figures? If you look at my figures, you see 175, 177. If you add them, you find a very interesting figure, which is 666. Some would say, okay, it's the figure of the Bible. I don't know.
Beast.
Sorry?
Beast, isn't it?
Who knows? I do not enter in these considerations, but it's interesting. A lot of figures also are figures which are found in the pyramids. The neutron is a sort of pyramid, you see, which has 4 sides, 4 triangles. If you calculate the length, the height, etc., you will find certain of my figures. I've done it. I say it to you because some are interested in these esoteric things. Maybe the pyramid are figuring out a neutron. Who knows? Okay, this is still open. A lot is open. Discussion on physics, of course, and discussion on the rest, esotericism, etc. Because I have solved nothing. I just said, okay, these 4 forces, interaction, we know we can put in one force, which is the force of creation of mass, and antagonism, anti-mass. But I have solved anything. The answer is in the mass of God. So this is. Thank you for your attention. Of course, if you have questions, I don't know if it's time for questions. Yes,
I have a lot of questions.
So maybe coffee time or tea
I don't
time.
know. Well, let me just list
Yeah.
a couple of them. So let's start from the very end. So But this triangle that you drawn here is it's self-contradictory. Like,
Yeah.
So.
I know there is a contradiction because in fact this is d1 multiplied by d2 minus d2 d1.
It's not only that, but it's this, if you set theta equals to 0, then d squared would be 0. It's just.
If this is 0, yes, it tends to 0. If this is 0,
Yeah.
all are 0. I agree.
Yes.
I say it tends to 0, so this tends to 90 degrees. Because the distance between the two masses are so little compared to the distance of the whole universe that you can consider that, you see.
Well, then you can consider that d squared is so little.
Okay. But it's a concept. We can discuss about that and
Okay.
no problem.
But I also have a general problem with
Yes.
what you said, that you have a center of the universe, which means that the universe again has definite size. Well, if you heard my presentation yesterday, I just disagree with that.
Yeah. It's actually, I said it's the center of the universe where it's everywhere, because there is no time and no space at that moment.
So we can take that point in any point?
Yeah, exactly.
Well, then that theta would not necessarily be 0.
Yeah, okay. It is also a tendency. You see, you cannot in the world of matter, you cannot have the exact thing. In principle, we should be only immaterial, because what I have said is all this mass which has disappeared in antimass is somewhere. It could be dark mass. It could be a part of our soul, because we are made of matter and antimatter. It could be our soul. All this is open. Of course, I cannot come in this consideration. I am a scientist, I'm not a philosopher. But it's a possibility. We are not only our body, if I may say so, material body. We are also our soul. What it is exactly, it's difficult. Some of you have better answers than me on that, you see. I can just say that according to that theory, yes, there is a lot of mass lost into antimass, which is zero mass, which is outside time and space, and which exists. And what we are able to do with our spirit, with our soul, we're able to project us in space and time, etc., etc. We're able to do that. How could you be able to do that with our material brain?
But we exist in time.
Yeah,
and
exactly.
space.
We exist in time and space, yes. Yeah, there is a lot of contradiction, but which are, I agree with you, these contradictions are the contradiction of, we encountered always. Why is there something? Does it come from nothing? Does it come from God? All these questions are open. I cannot answer these questions. All I do, I have an hypothesis for putting together the four interactions. That's all. This is what I do. You see, the rest is some thinkings and some ways of discussing. Yes, please.
Let's then go back to your tables.
Mm-hmm.
So I wish to ask, like, what do these numbers correspond to? Like, basically, I imagine that you have some sort of, as you said, you had some equations, which means that probably you have some dynamic going on inside these particles, right? Some structures. So can you comment a little bit, like, what's going on, basically?
Yeah,
What are we dealing with?
Yeah, actually, my hypothesis is that, and this is in line with Einstein and more, we discussed it a little bit yesterday with Henri Poincaré. Henri Poincaré is not well known by you. It's a French scientist who discovered before Einstein the equation of Einstein, called Einstein. But it was attributed to Einstein because the explanation by Einstein was better, considered better than that one of Henri Poincaré. Einstein based his explanation on the invariance of the light speed. Okay, and Henri Poincaré had other explanations which were considered as non-possible. I say it's not so easy, because mass plus antimass demonstrates that there could be zero mass. And then at the limit there could be zero mass, and then in that case it's not explained by the invariance of the light speed, but explained by Henri Poincaré. Okay, this a discussion we can discuss long about that, of course. This is so. My guess is that, of course, a mass is entering the space-time, coming from somewhere, entering the space-time. This mass is creating the space, the time first, as I showed, the time, the line, and then time plus mass equals space. Actually, without mass, there is no time, no space. You see? Also, you can say, but the photon has no mass, but time and space is in time and space. I agree. But we have not to forget that the photon could also be, how do you call that in English, entangled, etc. So there are new theories about that, which are still to demonstrate. But maybe my system could, in a certain way, help. I hope.
How? Can you talk to that a little bit, how you might think that it might help us?
It might help us, first of all, for binding energy. That's okay, this you know. It's because I have chosen binding energy because it's the better material to demonstrate it, actually. Because the weak nuclear energy can only be demonstrated by the difference between the neutron and the proton. The mass itself, it's my table, so it's my hypothesis. Electromagnetism is also my table. It's an hypothesis, but binding energy is a real thing, you know. And why is there a certain binding energy of deuterium, of alpha particle, etc.? Nobody explains it. I can calculate it, and I have also explained it. So this is an illustration of the possibility of my theory, but it's, of course, again, to discuss. Everything is open. Yes.
And I have probably the last question.
Yeah.
What do you think about the matter-antimatter symmetry?
Oh yes, I speak about mass, antimass, creation of mass, which is, I use the French word of massification, not materialization, not matter, mass, massification, demassification, which is not the same. Matter is the following, it's mass plus charge. So for me, it is a mass, like I demonstrate, plus a charge, electromagnetic charge, like I demonstrate. So it's something different. And of course, you can have matter and antimatter, but it's different to mass and antimass. Mass and antimass are coming first.
So just to clarify,
Yeah.
the mass defect, does that come from your calculations with the mass, anti-mass, and,
Yeah.
and that's the values of the mass defect that we
Yeah,
see
yeah,
in all
exactly.
the different
Yeah, yeah.
elements? Right.
Time? Okay. I couldn't run. Sorry.
Well, I don't understand what you've done, but here we have Pascal's triangle, and this is just x plus y to the n, and you've gone on, and all the coefficients in there are just that. But I don't know, you'd have to explain again why, but then you stopped it at 18, and you had some argument that if you went beyond 18, things went wrong. So
it is exhausted. You see,
yeah, but
after
what do you mean by exhausted? Why not? Why not stop at 6 or 99?
Yeah,
I mean,
The table is like that. It's the reason why I have chosen that table as that matrix in order it works. You see, of course, you can say it's not an explanation; it's an artifact.
Right.
Nevertheless, I agree that at the end I have to find something to materialize these things. Nevertheless, if you do that always in the same way, you find the result which is correct. So only one, let's say, system, which is mass plus minus mass, in a certain way. I just demonstrate line per line, and
well, these lines are like it's a pair production and then destruction, and then goes on
exactly,
like that.
exactly.
I mean,
This will always be massified, demassified, etc. In sort of waves.
Okay.
The result we see are waves actually. See,
well, okay. So at every level, I mean, do these levels have meaning? You're saying we got to level 18 or something, and it means that this is that a neutron or a proton, or the neutron turns into a proton, whatever you said there. But do the other levels have any physical meaning?
Yes, of course.
What
They
do
have a
they mean?
physical meaning. These are destroyed, but is annihilated in electromagnetism and other things. You see, it's
So will they be seen in the shower of collisions in the CERN nuclear? You know, you'll see these different. So these are going to be
exactly. So yes, this is maybe
measurable energies or matters or whatever.
So if you can take my paper summarizing,
Well, I'd like to read it.
You,
if I
you
could
will
understand
see
it.
some pions, pion, maison, etc.
Okay.
The mass of the pion, the maison, etc., which are deducted from that.
Well, that's magic if you can do that.
Well, not so much.
Yeah.
Yeah, you were
Okay.
first. So sorry, you were.
Just a quick one. In one of the presentations in Bath, we heard about the idea of the tessellated structure
Yes.
and how that might account for the movement of charge, etc., etc. Do you see that as being overlapping with this idea?
It's not overlapping. It's overlapping. It's the same, but I did it in a practical way, because what Tim Booker presented in place of Volodymyr, I don't remember his name, is a theory. I totally agree with that theory. I totally agree with that, and I will write to that guy when I am home. Nevertheless, I have taken the figures, you see, in order to be a bit more concrete.
It shows the same process of movement.
It's the same process, exactly. Who else had a question?
Over there. Oh, well, I was thinking, you mentioned gravity, and can you speak to gravity from your perspective, how you see that, what it is? Because gravity, even in our own communities, it's the most mysterious one still. Can you speak a little bit to that, how that...
Yeah. I say first of all, there is no... there is two systems of gravity, according to my views. Huh? There is first the inertial mass, mass, and then the gravitational mass. Everybody thinks that inertial mass is equal to gravitational mass. I agree that everybody agrees on that, but I disagree on that. I say it's not the same, it's practically the same, but it's not the same at the very end. At the very end. And what I demonstrate here is actually inertial mass had nothing to do with gravitational mass, because we are at the level of the neutron, the proton. They have an inertial mass. And the reason why mass defect, etc., is not due to gravitation directly. Okay.
Right, gravity has no place in the atom or the nucleus.
Primarily,
Well,
primarily, okay. We can always discuss that.
Well,
But,
why not?
okay. Then the gravity we know, that one of Isaac Newton, is completely different. You see, first of all, it's valid in a local universe, I would say. Not valid as we have seen in a bigger universe. And I use m divided by d, which is what others have found, to demonstrate this the validity of the inertial mass, and also the link with the gravitational mass of Isaac Newton.
Philippe, are you sort of nearly ready?
It depends on the gentlemen and ladies.
Okay, I think that coffee will be ready in a second.
Okay.
Don't move for a second.
Oh.